Hello friends, let's continue with our discussion on frames. Okay, in the later part of the frames, we have certain concepts like meta class, mutual disjoint, is covered by, and so on. In my last video, we had seen how we can represent a frame system. Okay, now we will see some different types of frames. Meta class, a special class whose elements themselves are classes. Okay, so you must be remembering there was something called as containership in object oriented programming with respect to C++. Okay, a class within a class is a containership. Similarly, meta class is a class that has another class as its member. Okay, so if X is a meta class and Y is another class which is the element of X, so that means if X is a meta class and Y is another class that is contained within X, okay, then it is obvious that Y inherits all the attributes of X because Y is contained in X, correct? So that is a meta class concept. Now other ways of relating classes to each other, there is something called as mutually disjoint. Now two classes are mutually disjoint if they are guaranteed to have no elements in common. Okay, so two classes are said to be mutually disjoint if they are guaranteed to have no elements in common. Okay, now in our previous example, person and adult male, they are not mutually disjoint. Why? Because they have some elements in common, right? The next concept that we are going to see is covered by relation. Now this is a very interesting relationship. A relationship is called as a covered by, okay, when we have a class and it has set of subclasses, okay, the union of which is equal to the superclass. Relationship is called as covered by when we have a class, assume that this is a class, and this class has set of subclasses. So you can see fielder is a ML baseball player, pitcher is a ML baseball player, catcher also is a subclass of this, American leaguer also is a subclass of this, national leaguer also is a subclass of this. So all these are subclasses of ML baseball player. Okay, so a relationship is called as covered by when we have a class and it has set of subclasses. We have a class and we have set of subclasses, the union of which is equal to the superclass, and the union of all these classes will be equal to the superclass itself. Also note that fielder and pitcher, they are mutually disjoint. Okay, so let us see how is covered by relation can be represented in the frame. Now according to our previous example here, see there is a class called as baseball player, and fielder, pitcher, catcher, American leaguer, national leaguer, all these are subclasses of a superclass baseball player. Also, since they are mutually disjoint, okay, the union of all these classes will give you ML baseball player. So now we are going to see how do we represent in frame structure is covered by relationship. Okay, so you see here ML baseball player is covered by, and in brace you write pitcher, catcher, American leaguer, all the subclasses. So that means baseball player class is covered by all these classes. Now when you define individual class like pitcher, then pitcher is a ML baseball player. And as I've told you, okay, as I've told you that pitcher and fielder, they are mutually disjoint of each other. So that you can represent here. Okay, pitcher is a ML baseball player. That means pitcher is a subclass of ML baseball player, and it is mutually disjoint with catcher and fielder. So that means pitcher is mutually disjoint with fielder and catcher. Okay, just an example. Similarly, catcher is a ML baseball player and catcher is mutually disjoint with pitcher and fielder. So catcher is mutually disjoint with pitcher and fielder. So all these three are mutually disjoint of each other. So when you define each of these classes separately, you need to also define mutually mutually disjoint relationship with respect to each other. Similarly, fielder is ML baseball player and it is mutually disjoint with pitcher and catcher. So fielder is also mutually disjoint with pitcher and catcher, and so on. So this is how you represent is covered by and mutually disjoint with relationships. Okay. Now we have come to a very interesting concept. This is basically a problem that that is present with semantic nets. Semantic net basically is a graphical diagram, okay, and it purely works on the principle of hierarchies, on inheritance. So there are some hierarchies which are called as tangled hierarchies. So next we are going to see what are these tangled hierarchies. Tangled hierarchy. These are the hierarchies that are not trees. Okay, now in object-oriented programming we have seen there are different types of graphs. Okay, there is something called as hierarchical inheritance, right? Now tangled hierarchies are the hierarchies which are not trees. You might have a graph in that. Usually the hierarchy is an arbitrary directed acyclic graph. Tangled hierarchies are very difficult to solve and it requires a new property inheritance algorithm. Okay, why? We will see. Before we take up the property inheritance algorithm, I would like to explain you what exactly is tangled hierarchy. Okay, before I demonstrate to you this particular example, okay, recollect the problem that a multiple inheritance faces. Okay, and there was a necessity of virtual base class in C++. Now what happens in this case is basically this is a semantic net pertaining to a bird called as Fifi. Okay, so there is a class called as Fifi which has an attribute called as fly and the value of that attribute is unknown. Let's go further in hierarchy sequence. Fifi is a bird, a pet bird. Okay, so Fifi is a pet bird. Fifi is a subclass of superclass called as pet bird. So all the attributes of pet bird along with the default values, if there are some, will be directly inherited by Fifi. Further, what is pet bird? Pet bird is a bird. Pet bird is a subclass of a superclass called as bird. And the bird class has a fly attribute with the default value as fly with the default value as yes. Okay, bird class has a attribute whose default value is yes. Fly's default value is yes. Okay, now since pet bird inherits bird, it will inherit even the fly attribute and its default value. So pet bird's fly attribute will also have value yes, and as a result, since Fifi is inheriting pet bird in return, the fly attribute value of Fifi will also have value yes. But we have seen only one side. Now if you see the other side, Fifi is also a ostrich. Okay, Fifi is a ostrich. So ostriches is special type of pet birds which do not fly. So fly attribute of ostrich is no. So if you consider this side, okay, from this side, fly attribute of Fifi will have the value no. Ostrich is a bird. Okay, ostrich is a bird. Although ostrich inherits bird class and as a result it will also inherit the fly attribute with the default value, but you see here ostrich, it modifies the default value of fly, that is yes, from the previous class now as no. So if you consider this side, the fly attribute of Fifi will get value no. If you consider this side, the fly attribute gets value yes. Okay, so this is basically something called as a tangled hierarchy, wherein there is a confusion whether the answer is yes or answer is no. Now in general, when you ask the question, can Fifi fly? In reality, the correct answer must be no, Fifi cannot fly, because although most of the pet birds in general can fly, okay, but there are subset of birds who are called as ostriches, and we know that ostriches, they don't fly. And since Fifi is an ostrich, the answer must be no. Okay, right? So this is in reality, the answer should be no. But here what happens is, one side you can get answer as yes, other side you get the answer as no. So there is really a confusion whether fly attribute value is yes or whether it is no. So this is called as a tangled hierarchy. Okay, we'll take up another example. Now this is basically Quaker and Republican. These are some political parties from US. Okay, and now Jack is a politician, and Jack is an object instance which has a attribute called as pacifist, whose value we need to determine. Now it is given that Jack is an instance of Republican, and Republican class has the pacifist default value as false. So if you consider from this side whether Jack is pacifist, from this side it is false, he is not pacifist. Quakers are pacifist in general, so if you consider this side, Jack is an instance of Quaker and Quakers are pacifist. So if you consider from this side, the pacifist attribute value is true. So this is also another example. So if the question is asked, is Jack pacifist? The answer is ambiguity, because in this case also you can't get the answer. Now there's a difference, small difference. In the previous figure here, okay, although the inheritance wise, the inheritance concept wise, it is difficult to find out whether fly is true or fly is yes or no. Okay, but in reality, using common sense, anybody can tell you that the answer of fly is no. It must be no. Okay, but only problem is, since this is a hierarchy and since inheritance concept is followed, Fifi, its attribute called as fly, its value comes to be ambiguous. But in general, in reality, it should be no. But in this case, in the figure B that we are going to see, whether it is inheritance wise or in reality, in common sense, both this, the answer is always ambiguity. Right? Now let us see some methods to solve. One way to solve the ambiguity is to base the new inheritance algorithm. So we are going to define a new inheritance algorithm based on the path length. Okay, there is a concept called as path length. So what is path length? Using breadth first search, okay, start with the frame for which the slot value is needed. Okay, using best first search method, start with the frame for which the slot value is needed. Follow its instance links and then follow either links upward. If the path produces a value that can be terminated, as can all other paths, once their length is exceeded that of the successful path. I'll just explain you what exactly this is. You just go to the previous figure, and now using this new inheritance algorithm that we have just defined, okay, let us try to figure out what is the correct answer we get for this figure. Okay, what it says is, using breadth first search algorithm, start with the node. Okay, start with the node whose value it's supposed to be determined. Okay, now we know that breadth first search algorithm, it goes breadth wise. Okay, and you go upward then from here through going through the either and instance links upwards, and whichever answer that you get first, suppose from this side if you go back and this answer you get first, so that will be the answer. Okay, if this yes is a lengthier answer, then that won't be the answer. So let's start and see what exactly this means. So you need to determine the value of this node. So using breadth first search, you go upwards through either links. So first you go here, okay, and then you go here. Now when the depth is 1, the answer of fly attribute is no. Okay, so after this is discovered, then here, from here you go to the next node, and the answer you get here is yes. Okay, from here also the answer you get is yes. Now you find out what is the path length between this no answer and what is the path length between yes answer. Now from this node, the path length taken to reach this answer no is 1, because you have to traverse one link. From here to here the path length is 1 to get the answer no. Whereas from here to here to get the answer yes, the path length is 1 and 2. Right? To get no answer, the path length is 1. Whereas to get yes answer, the path length is 2, 1 and 2. So which answer to be considered? Yes or no? Whichever answer that gives that is based on the lowest path length, and that is no. And that's why the answer of this you get as no, which is correct answer. Understood? So I will recapitulate what we need to do. We start from the node whose value is to be determined, and using breadth first search you traverse upwards through easer and instant links. Okay, so when you go upward, first node that you get is ostrich with fly attributes value as no. The path length till this is 1. When you go from this side here, you are not getting any answer. Then when this is expanded further, you go to the bird node with the fly attribute value as yes. Here also you reach the same node. Now we calculate what is the path length from this node to the first answer. The path length from Fifi to ostrich for the answer no is 1. Whereas the path length from this node to the answer yes is 1, 2. Which path length is lesser? 1 or 1, 2? 1 is lesser. So the answer retained is no. So this particular new algorithm that we have just considered, it solves a problem with respect to this diagram. Let's see whether it also solves the second diagram. Now here you need to find out whether Jack is pacifist. So using the same algorithm, okay, from the node whose value to be determined, using breadth first search, you traverse upwards through the easer and instant links. So when you go here, okay, you reach the Quaker node with the pacifist answer is true. But when you go here, Republican, the pacifist value is false. The path length from this to this is 1, from this to this is also 1. So since the path length are equal and you are getting two values, you are still in the ambiguous state. So it gives you ambiguity. So the problem here is not solved with the version of algorithm that we have seen. Thus, using the technique of ours, the answer to the Fifi problem which we had seen, figure A, is no. And for Jack problem, that is figure B, we get two values, hence contradiction. Okay. So in our next video, we are going to see how our new algorithm that we have just determined is faulty and what modifications are required for that. Okay. Thank you.